All right, welcome back, everyone. We'll begin in just a moment, so get everything situated. Hope everyone's doing well. I'm still a little tired from the 24-hour stream, honestly, I think. Took a little quick nap for the stream. Turn off this music. Alright, yeah, and as I was saying in the chat, I just started making a few shorts. I think I'm losing my voice too. Feels a little weird. But I started making shorts on YouTube, so yeah, I would appreciate it if you like them, or if you like them to go like them. But yeah. Why am I getting notifications on here for Discord? Oh, maybe that was my phone. Okay, so yeah, we're just continuing, and then tomorrow we'll do some exercises. I know somebody in Discord just posted a log problem, so I'll take a look at that one. Sorry, my phone keeps making these Discord noises. All right. So yeah, we've been talking about probability lately, random variables, and now we're starting to get into some random processes. So I put in the resources. We're going to start talking about this Shreve book. So this is lesson 20, binomial asset pricing model. Okay. So this is, I mean, I kind of hinted at what this process is before, and we worked out a probability problem based on it, but we weren't including one of the important aspects, which was the risk-free rate. So yeah, the simplest model is we just have one period of time where the stock or the asset or the random, whatever the thing that has some random quantity attached to it is changing over only one period. So this is like a super simplified model. And surprisingly enough, this really simple model is actually telling us a lot of important things. And the fully general model, where you have many periods, all the calculations are very similar. So Shreve starts out with just this one period model. Binomial model. Wow, this marker smells strong. Hello, Rex, trying out all the commands. So binomial means that there's only two options, essentially, right, for each period of change. So you're basically modeling your stock as some initial price, and it has some p probability that the price will increase by some u amount in proportion. So it'll be u times s naught. U is some percentage. It's usually greater than 1. Or in fact, I think, yeah, we'll show in a second, it needs to be at least the risk-free rate, I think. So with probability p, the stock increases by like u percentage, or it's like basically u percentage plus, well, it's like 100% plus u, right? U is usually some number near 0, like, maybe it's like 0.1, 0.2, 0.3, something like that. Or actually, sorry, u is like 1.3, 1.2, so it's like the percentage I was just talking about plus 1. Yeah, so usually u is like around, like 1.1, 1.2, 1.3, something like that, in that type of range. And then with the other probability, which is always Q, which is 1 minus P, it might go down by some other proportion. You're treating the strike price as... We haven't gotten to strike price yet. No, this isn't strike price. This is just the stock price itself. So this is just a very, very simple model. We're just saying the stock goes up by some percentage with some probability, or it goes down with some other percentage at the other probability, at the complementary probability. So nothing about... Let me turn up... I don't know if the volume makes a difference, but turn up the volume a little. So yeah, I haven't said anything about options yet. This is just some stock price can go up, it can go down. Yeah, and these are the only two things that can happen. Okay. And sometimes we'll call this, it's like we flipped a coin. So this, you can think of this as like the state that results from the probability state of flipping heads. So you could think of this as, it's S1 of heads, and this is S1 of tails. So it's like we flipped a coin, and based on what the result of the coin was, except the coin is not really a fair coin unless P is 50%. But we flip this like non-fair coin. If it's heads, then the price goes up. If it's tails, the price goes down. That's all the model tells us. The next not even money trade occurs with increase or decrease. If the trade at the same price, right? So in this model, it can't trade at the same price. These are the only two things that can happen. So one period of time goes by and either it goes up or it goes down. That's it. Nothing else can happen. So it's obviously a very simplified model. Stock prices can move basically at any increment of 0.01 usually. So not exactly a realistic model, but as you'll see, if we allow the number of periods to get larger and larger, the accuracy of the model gets better and better. And the amount of values that we can hit as the periods grow also gets more fine-grained. Jeff says, and we put no restrictions on U and D at the bottom. Yeah, I'm about to write the restrictions. So the restrictions are, let me write one more thing. So there's one more quantity, which is this risk-free rate. So we're assuming the risk-free rate is R, and that means that if I start out with X cash at the beginning, cash, and then I'm going to write the condition right here that's the last room I have, but so the risk-free rate being R, this is a quantity R, it means that at the beginning of the period, if I invest X amount of cash into, you're thinking of this as like treasury bills or some overnight rate at the Fed or something. If I put X dollars at the beginning of the period, and then at the end of the period, I will have X times 1 plus R. So basically R is like this return that I'm getting just for not taking any risk, just for, loaning your money to the government, basically. Used to be didactic fractions. I don't know what are didactic fractions. Oh, well, didactic sounds like two something, but yeah, so the condition here with the R, the U, the D, yeah, R, U, and D is that 0 must be strictly less than D, must be strictly less than 1 plus R, must be strictly less than the last one, U. Which just means that like you're getting paid more than the risk-free rate to take risk if you're successful, and if you're unsuccessful, then that pays you less than the risk-free rate. So this risk-free rate is like somewhere in the middle, right? So I'll just write like 1 plus r here. Right, so it's a binomial model with the price of the stock, but of course we can always take some of, if we have cash, we can always split our cash up into buying some amount of the stock and investing the rest as cash, or actually technically a lot of the times with these options we're going to be actually borrowing money at this rate. So this is the rate at which we borrow or at which we get paid interest. So either we're paying interest or getting paid interest. Yes. Oh, right. I forgot to write the book. Thank you, Mavut. Right. Yeah, it's in the chat right there. Right. I forgot to write that. Thank you. Right. Okay. So that's essentially the setup of the model. It's very simple. You just flip a coin. Maybe it's like an uneven coin that has probability P of heads, 1 minus P of tails. If it's heads, the stock goes up some amount, U times S naught. If you flip tails, it goes down, D times S naught, and you need that 0 is less than D is less than 1 plus R is less than U. And essentially what we're going to show here is that there should be, I haven't written what an option yet is, so let me just stick to this for a second. Is there any questions with this model? Oh, I forgot to hydrate. Sorry, Rex, I just saw that. Well, I have coffee here. I don't know if that counts. Does that count as hydrating? This is probably dehydrating, actually. Okay, so essentially where we're going to go with this is we're going to talk about an option on this stock in this model, and it'll pay a certain payoff if we're correct and the stock goes up. We'll get some payoff based on the strike price of the option, if it's a call option. If it goes down, we'll either get less money or we'll just get 0 based on if the strike price is higher or lower than this D times S naught value. Coffee is dehydrating, yeah. Coffee costs more points. All right, I'll have to redeem those, or I'll have to, what's the word? Not redeem. Refund those points. Okay. Right. So we're about to basically write down what is an option. We have call options and put options. They have different payoffs based on what happens to the stock here. And yeah, we're going to try to show that there's a way to only trade in some amount of the stock and essentially reproduce the outcomes that happen from the option. So we're going to show that there's a formula later that I'll write that says we can replicate the payoffs of the option based on just trading in this underlying stock. So that's the idea. Okay, so what does this replicating portfolio look like? And there's one important thing that I want to point out here, which is that this P and this Q here, these are the real probability that the stock will go up or down, but actually these don't figure into the equation for calculating the price of the option. So it actually doesn't matter what the probability is that the stock will go up or down. We're essentially going to replicate a portfolio that reproduces the value no matter if it goes up or down. So we actually don't care about these probabilities. But obviously if you're trading in real life, you care about these. Because in real life, you're going to probably take some risk. So these will actually affect you. But in terms of what the price of the option actually is, these don't matter. Because the person that's, can replicate the formula can basically take no risk and ignore if it goes up or down. Okay, so let me erase this. Any questions? This marker is like really good. It's almost too good. It won't erase. Okay, so yeah, we're going to talk about a replicating formula, or a replicating portfolio, I mean. Well, it has a formula for the replicating portfolio. Okay. Can you explain it? Oh, right. Yeah, can I explain why the restriction, right? So, what was it again? Oh, right here. Yeah, so this restriction, yeah, the reason this restriction exists is because I believe you would be able to make basically some risk-free profit. Like if the D was larger than this, then no matter what happened, you would always make more than the risk-free rate, whether the stock went up or down. So that would be a problem because essentially, yeah, it has to do with it has to do with no arbitrage conditions. Essentially, if D is bigger than this, both U and D are larger than the risk-free rate, so you can make like money for certain risk-free. Or the other way, if U is less than 1 plus R, then essentially you're always you would never invest because you would just put all your money in the risk-free rate, because any amount of risk you're taking, you're actually making less on average, because the average of D and U is going to be somewhere in the middle. And if they're both less than 1 plus R, then there's no point in investing in the stock, essentially. Or you could short the stock and make, instant money, essentially. Yeah, you would have to like borrow money at the risk-free rate, then short the stock, and then instantly, no matter what happens at the end, you buy it back and you make money for free. So, yeah, essentially this is a no arbitrage condition. If this isn't satisfied, then there's a way to set up your portfolio so you just make money for free and you don't take any risk, essentially. So then it's kind of boring. Yeah, I mean, so you could have U on the other side, you could have D on the other side, but then you're just basically, you're just not going to be investing, or you would be shorting with some arbitrage trade. No one would see if D is greater than 1 plus R for, yeah, no one would sell, yeah, exactly. Yeah. You would just keep buying the stock, because no matter what happens, you're going to be making more than the risk-free rate with no chance of making less. So yeah. Okay. So the replicating portfolio is going to ask the question. Oh, actually, yeah. Let me talk about what the option is first. I guess it's not going to make sense without mentioning what an option is. So the definition of an option is pretty simple. So an option, let's just talk about call options for a second. So it pays some value, which is usually the maximum of S1 minus K, or 0, at T equals 1. The end of the 1 period. Yeah, and this is just saying that essentially the call option is paying you the difference of the value of the stock at time 1 minus K, or if this value is negative, it just pays you nothing. So it has this payout curve that is sort of like convex like this. It's not, yeah, it's obviously it's not a differentiable because it has this cusp right here, but it still has this convexity to it, and that means that the expected value is always going to be larger than the the value of the payoff at that point, like we were talking about with a couple of the problems from last week. So essentially, we're gonna write our same model here, but now it's going to be for the value of the option. So v0 is going to be the value of the option at time 0 at the beginning of the period, and this is going to be the thing that we want to calculate what this is. And it still has the same probability P, probability Q, that it goes up or down, but now this is going to be the value of the option if the stock goes up. And this is going to be the value of the option if the stock goes down. And we know what these values are. Who could tell me what the value of this option is if the stock goes up? Well, I basically just wrote it right here, right? This is the max. I guess this just depends on whether this is positive or not. And this is also. The difference. So essentially for a call option, you're just getting paid the difference between the end price and the strike, or if it's negative, you just get nothing. Okay, so then the question is, how do I compute the initial value here such that I can create a replicating portfolio based in the stock and money? So I can put some amount of money in that risk-free account, or I can borrow money at that risk-free rate, and then I can buy some number of shares of the stock, and based on that replicating portfolio, there should be a way to set it up so that if the stock goes up, the portfolio is worth this V1 of H, the value of the option at time 1. Or if the stock goes down, I can set it up so that the value of the portfolio is equal to the value of the option for the other event happening. Okay, so that's essentially what we're going to do. We're just going to set up a portfolio. It's based in cash and stock. There's some amount of cash and some amount of stock, and we're going to try to figure out how much money I would need at the beginning so that I could do this split, make a replicating portfolio, and basically hedge both conditions, whether it goes up or it goes down. Okay. So yeah, maybe I'll write this in another color. But this is kind of the setup of the portfolio value at time 1. So at time 1, I'm going to do this in orange. So at time 1, we will have some amount of value in our portfolio, which is x1, and this is going to be delta 0 S1. So basically we're going to buy some delta 0 number of shares, and then the value of our portfolio will be delta 0 times S1 at time 1, plus we invested some amount of cash at the risk-free rate, so plus 1 plus R times how much cash did we invest? Well, it's X naught minus the amount we put in the stock. At time 0. Yeah. So the value of our portfolio of cash and stock at the end will be however many shares we bought at time 0 times the new price at S1 plus however much cash we had left over times the risk-free rate. And this can be negative also. All right, I see the ads. I'll just stop for a couple minutes, but yeah, this is the setup. So let me know if there is any questions. So if call option, this is the payoff function. In the 1 period model, it can either go up or down, and we have some payoff in both cases. And if we want to create a replicating portfolio, the value at time 1 is going to be based on how much stock we buy, which is this. So it's going to be based on how much stock we buy, and also indirectly on how much cash is left over that we invest at this risk-free rate. Okay, so any questions, Jeff? Anybody else? this is a little messy, so I'll try to separate this a little. All right, so this is just like our last model, except now we're trying to figure out, now we're modeling the price of the option instead of the price of the stock. But obviously there's a direct relationship between the two. Just wait for that to be over. Okay, so no questions. I'm gonna move on. So yeah, now we want to know how much should I buy at time 0? And based on that, we'll show that there's some sort of formula where we can compute what this value should be. But one thing you should know is that this value is definitely not going to be the average, the weighted average of these two. So has anyone seen this before? Can anyone explain to me why the value of the option is not just the average, the weighted average? Like it's not P times this plus Q times this. You might think that like the value should just be the average of what I'm expecting to get, right? Sort of seems like it should be that way, but who can give me like a intuitive explanation for why I can't just take the average of these two, like P times this plus Q times this, and just that's my price? There is a chop at 0. I don't think that's the reason. You're saying because of this discontinuity in the derivative, you're saying? I don't think that's the reason. I mean, it's a good question, right? Because you might think this kind of goes back to the question I started on the board the last week on Friday. Right? It was like, how much should we bet on this thing? Should it just be the expected value? There's no chance of negative return? What do you mean? Well, I mean, if I bet on this, I can definitely lose money, right? Depending on what this is. I mean, this could be 0 and this could be non-zero, right? Like this could be non-zero, this could be 0, this could be non-zero, and I could still lose all my money. Well, the call itself is not risk limited. The replicating portfolio we're trying to create will be risk neutral though. So that's the key here, is that remember I said that these probabilities don't matter, right? So the price of the option shouldn't depend on P and Q. Because we're trying to price this option based on no matter what happens. So it shouldn't depend on the probability of the stock going up or down. Yeah, I'm going to do concrete numbers in a second. Yeah, that's the next example I have. But I just want people to just think about it before I do the example. When I do the example, it'll be obvious, I think. So I just want to get a feel for what people might be thinking about before I do the example. But I think you're close, Jeff. I mean, the call itself, the risk is not limited. Oh, to the call. With the call, wait, maybe I misread it. With the call, your risk is limited to the call price. Okay. Oh, right. Yeah, I mean, that is true. It can't be negative, right? But it can still go down. I mean, so there is some risk, right? If you buy whatever this price is, if it's non-zero, it could go down. So I think the idea here, which maybe you're close to, I don't think you have it exactly, but the idea here is that you're taking some risk. So assuming this is non-zero and it can go lower, if you just buy the option and you don't create a replicating portfolio to like hedge it, it's possible that this could go up, it could go down. So just buying the option itself is taking on risk. So the price of the option shouldn't just be the raw average of the two, because that would essentially be the price of, for the expected value to be 0. That would be like a, how do I want to say this? I guess the probably the example in a second will make more sense. But yeah, the idea is that these P and Q are based on the real risk of the stock changing value, and we sort of want to come to a price that doesn't depend on these probabilities. So it has to do with the risk neutral stuff, because P and Q depend on the risk, essentially. So there's like a change of measure, quote unquote. I don't want to go into exactly what that means, but there's essentially some new P and Q that we can view that are called like the risk neutral measure or risk neutral probabilities. And in that new measure, then this will be the average with respect to the risk neutral measure, but it's not the average in the, I guess you can call this like the real measure, or how much the stock is actually changing. So what I'm trying to say is these are the real probabilities, quote unquote real. And the price of the option should not depend on these. Does not. On these. And I think the example will show that in a second. So yeah, just to summarize, I know it's a little messy. We're trying to figure out this option. We know what the value is at the terminal conditions, whatever happens. We know what the price of the option is. And we want to say that the price at time 0 is some sort of average, but it's not the average with respect to the real probabilities, because that would be like the value of it in the real sense, but not the risk neutral price. So the risk neutral price is going to depend on this, but we're going to have to change measure, which is equivalent to saying that we have to view the probability measure. We have to sort of do like a change of measure. We have to view these as different probabilities. Okay. So yeah, let me write down the formula just for let me finish these formulas, and then we'll do an example. I'll leave this up. Do you mean we just by R? Do you mean we adjust by R? What are you asking? I'm a little confused about that. You mean we adjust by R? Oh, for the risk-free measure, you're saying? Well, so the risk-free measure is the probabilities such that our average gain over the one period will be the risk-free rate. So it's possible that we have a stock that is going to go up with like 99% chance to $200, right? Let's say, and it has a 1% chance of going to $50, let's say. So, and let's say that risk-free rate is 0.05. So I haven't written down the formulas for these two yet, or for delta 0 and for V0. But even before we get there, let's just look at, so clearly the average here is not giving us the risk-free rate here. So that's the point here. So the change of measure is required. so that the expected value at time 1, expected value of S1 is the risk-free rate times S0. So in the real probabilities, like, I don't know, maybe this is just an amazing company and it's going to double every year unless there's like a 1% chance they go through some crazy event, right? So this company on average is going to make a lot more than the risk-free rate, but there's still some chance they don't, right? So the change of measure basically changes these probabilities. It readjusts the problem so that the expected value is just the risk-free rate, because when we construct this replicating portfolio, that's what we're going to make on average, is the risk-free rate. So when you say we're changing P and Q to compute the value of the option, but that adjustment isn't related to R. No, it is related to R. It's directly related to R. It's not related to the original probabilities. It's related to R in the sense that we need to adjust them. There's some P here such that when I do 200 times P plus 50 times Q, I get exactly, I get exactly this. Does that make sense? And this is expected value. So the expected value of the stock price at time 1 should be exactly 1 plus R times S0, but that's in the new measure. So that's when we change these to a new, and the new one we're going to call P tilde and Q tilde. So there should be some P times 200 plus Q P hat, or P tilde times 200 plus Q tilde times 50. That equals 105. And since Q is just 1 minus P, you can figure out what P would be, right? So yeah, and then there's a formula for P hat, so let's write down what that is. So the formula for P hat is always going to be 1 plus R minus D over U plus D, or U minus D. So 1 plus, put it here. So P tilde is always 1 plus R minus D over U minus D, like that. And so in this case, U would be like 2. This is U times S0. This is D times S0. Yeah, so you can see P hat depends on R, so yeah. And then obviously Q tilde is just 1 minus this. And there's a formula for that, but you can just remember it's 1 minus that. So you want P times U plus 1 minus P times D to equal 1 plus R. Yeah, I think that sounds about right. Yeah. Yeah, which then I think that just gives you this formula, right? Yeah, I think if you solve that formula that you just wrote down, you get this. I think. It looks right. Yeah. Yeah, so basically that's just saying that the average that you're going to make is 1 plus R. So if you want to think of what's going on in this problem in English, what we're saying is there's some probability, maybe we don't even know what it is, that this stock goes up, and some probability that it goes down. But even if we don't know the probabilities, there's still a way to create a replicating formula, a replicating portfolio, such that the value at time 1 is always equal to the value of whatever the option is, no matter what the stock does. And your average gain for the stock in this new measure that you need to compute this stuff is such that the expected value of the stock return, and we'll write in a second that the expected value of the option return is also this 1 plus R value. So that's saying that in the risk neutral measure, well, we haven't written down the formula for the option, but Yeah, yeah. But the expected value of the stock price and the expected value of the option should be 1 plus r times the original value. So S0 or V0, when we write down V0 will be the option price. Okay, so here's a quick example, but we'll do another example. Let's write down what this formula for this, how much of the shares we need to buy of the stock at time 0. And then we'll also write down a formula for, so this shows that the expected value of the stock price at time 1 is the average of the stock prices the stock price at time 0 is the average of the stock prices at time 1, but in the changed measure, in this new measure. So we'll show that I'll write down the formula for the option price at time 0. It's also the expected value, but of the option prices instead of the stock prices. And also with respect to this new measure, this P tilde. So, yeah. And then I'll do another simpler example and we'll write out everything. But yeah, I just wanted to give that quick. Okay. Oh wow, this time's going fast. Okay, so what are these quantities? So yeah, Shreve, it's like 2 or 3 pages, so I probably won't. It would take a while for me to write out the full argument here, but he goes through why this delta 0 has to be basically the price of the option at, if we flip the coin and we get heads, minus the price of the option if we get tails, over the price of the stock if we get heads, minus the price of the stock if we get tails. And I also want to point out that this is kind of like a derivative, and in the continuous case, the delta will actually be like the price of the option, the call option, C DCDS. So I just want you to think about the continuous case. This is like the change of the value of the option relative to, in proportion to the change of the value of the stock at time 1. And it's so in the continuous case, you have this like stochastic version where you're using like stochastic calculus, but this is like the discrete version of that. Happy Tuesday! So this tells you how much at time 0, how many shares of the stock I should buy, and then however much cash I have left over, or maybe it's negative cash, maybe I need to borrow cash. Usually I'll have to borrow cash to buy this stock, and I'll have to pay some risk-free rate on that cash that I borrowed. So if I buy this amount of stock at time 0, then at time 1 I will have this amount. So if the stock goes up to S1, I'll have this amount. If it goes down to S1, D times S0. So this thing can either be two quantities, but either quantity, it will be equal to V1 of H if the stock goes up, or it'll be equal to V1 of T if the stock goes down. So delta 0 represents leverage. No, delta 0 is just the number of shares. The leverage would be the value of my portfolio. The leverage would be how many shares I own times the original price. So I guess the leverage would be delta 0 S0 over X0. Yeah, I think that's right. So this would be the leverage. Or implied leverage. I guess it's like implied, really. It's not actual leverage. Well, I guess, no, this would, in the replicating portfolio, it is actual leverage, because we would have to borrow. Like, if delta 0 S0 is greater than the original amount of money I started with, then I would have to borrow money at the risk-free rate, and then once I had enough money, then I could buy the delta shares. So this quantity on the top might be bigger than the quantity on the bottom, and that would just mean I borrowed money. If this quantity is smaller than this value, then whatever cash I had left, then I plug that into the, I put that in the bank and I make 1 plus R times it. Tacos. Right. Let's see. What am I missing here? Oh, and then yeah. So then what's the value of the option at time 0? Well, it's very similar to what we had for S0. The value of the option at time 0 is going to be the expected value, but in the risk-free measure. So I'm going to write expected value risk-free, meaning that again we changed the probabilities. We had to solve them, right? That 1 minus what was it? 1 plus R minus D over U minus D, that was this P tilde, that was the new measure, the new probability measure. So it's the expected value of V at time 1 in the risk-free measure, which is just, oh, actually I'm leaving something out. Or no, this is right. Yeah, so this is a 1. Yeah. Or actually, I think it's, yeah, it is 1. Yeah, you need to divide by the risk-free rate because you need to, yeah, because you should be making 1 plus R on average, so, maybe I'm writing this right? Hold on. All right, let me get rid of this expected value thing. It's just confusing me. That's not the way he wrote it, so I don't want to write it wrong. But basically, V1 is going to be 1 over 1 plus R times the quantity P tilde, V1H, plus Q tilde times V1 of T. And so see, you can see how this is, it's like 1 over 1 plus R times the expected value of the value of V1, but in this new measure where we're using P tilde and Q tilde instead of the actual measure. So Jeff says, I mean, if E of anything isn't 1 plus R, then either no one would sell or no one would buy because it's guaranteed gain or loss. Yeah, exactly, yep. In terms of the replicating portfolio. No. Well, really what we're saying is if that stuff is not if the expected value in the risk-free measure is not 1 plus R, then you would be able to make risk-free profit by either buying or selling the option and then replicating the formula replicating the portfolio or the option using this formula. So either, yeah, if the option is selling for more than this value, then you're going to sell the option and replicate the portfolio using this formula, and you're going to make money for free. Or if the price of the option is below this number, again, you're going to buy the option and then sell short this portfolio, and then you'll make money for free. So the argument is that this is an arbitrage-free pricing, that this is the only price for the option at time 1, where you can replicate it and take no risk, and there's no arbitrage to be made. V0, you mean probably, yeah, right, V0, yeah. Yeah, so this is the no arbitrage price for the option at time 0, and that means that if the option was selling for more, you would just sell the option, replicate the portfolio, and pocket the difference. Or if the option was selling for less, you would buy the option, sell the replicating portfolio short, and you would make free money either way. So yeah, the argument is that this has to be the only price. It's the only price that makes sense, and definitely for the one model, for the 1 period model, this is, yeah, this is, if this is strictly the only things that can happen, then yeah, that's the only price. But of course, in real life, what can happen? Maybe the risk-free rate is not constant over time, right? So usually over a period of time, right, the risk-free rate is going to change. So that's probably not satisfied in real life. What else about this model is not accurate? So risk-free rate can change. I mean, that's sort of like, because remember, we don't need to know what the actual probabilities of this stock. Well, yeah, I mean, of course, a stock might not take only two values at time one, right? That's another thing, right? So risk-free rate can change. The stock doesn't necessarily only take two values, but when we add more periods, we're gonna get like a finer, like a fine-grained set of outputs or set of results for the stock price and the option. But yeah. Okay, so I think that's, so yeah, let me go over this example real quick. Next 5 minutes. So this is just a short, quick little example with some easy numbers. Math for money, nice. This is an interesting approach. You're giving us the formulas and showing us why they work. Yeah. No, I mean, the key here is that for it to be risk-free, you should expect to get the risk-free rate, and that's what the risk-free measure is telling you. Oops. So here, just nice little example to illustrate the 1 period model, and then we'll look at the 2 period model, I guess, maybe like Friday or something. Or I mean the multi-period. So let's say we have a stock, it starts at $100, and it has a 50% chance of increasing to $150 at the end of the year. Let's say the time period is just 1 year. So 1 unit, 1 year. And it also has a 50% chance of going down to $80. So Shreve points out that a lot of the times this percent increase will be the same as this decrease, and it makes the model like simpler, but there's no reason they have to be. So 50% chance it goes up by 50% and 50% chance that it goes down by 20%. So here U is actually 1.5, D is 0.8. 100 is a good number. Let's keep it so easy. Yeah, exactly. Yeah, $100 at the beginning. It can either go up 50% to $150, or it can go down to $80. So U is 1.5, D is 0.8. Let's just assume that the risk-free rate is 5%, just because that's like a realistic number. Okay, and then I'll let the ads take their course. And let's say we have an option to buy this stock at a price of $110, strike price. To buy at time 1. For K equals $110 per share. So what would the option value be at time 0? Well, if the price increases, we're going to get 150 minus 110. I'll slow down a little bit. Nobody gets that far. Yeah, Jeff. No, I mean, people should be getting ads, but I'll just slow down during the ads, yeah. So S0, 100, it can either go up or down. We said that now U is 1.5 according to these numbers. D is 0.8. Risk-free rate is going to be 5% because this is like 1 year, and I'm trying to make the numbers simple enough but also realistic. And then we have the option. It's a call option to buy the stock at t equals 1 for a strike price of 110. That means if the stock goes up, the call option will be worth $40 at the end. 150 minus 110. If it goes down, it's going to be worth nothing. So it seems like the call should be worth like $20, right? That's what it seems like it's worth. But that's not the risk neutral price. That's not the price of what this replicating portfolio would produce, giving us a risk-free return. So we have to change measure to this p tilde. This is going to be 1, keep forgetting this formula, 1 plus r minus d over u minus d. This, in this case, is 0.25 over 0.7, which is around, let's say it's about 0.3571. And that makes Q tilde approximately 0.6429. Okay, so actually in real life, the probabilities were 50-50 that it would go up to 150 or down to 80. But in the risk-free measure that we need to change to calculate the price of the option, so these aren't real probabilities. These are basically like fictitious probabilities. These are only to calculate the price of the option. These have nothing to do with real life. But if we change measure and assume that these were the probabilities, then that gives us the price of the option. So this is going to be 1 over 1 plus r p tilde times v1 plus q tilde times v1 of h. This is just too messy. Let me rewrite this. So this is v0, and v0, we have a formula that says this is 1 over 1 plus r p tilde v1 of h plus q tilde of v1 of t. So this is 1 over 1.05 times like 0.36-ish times 40, or yeah, because the other one's times 0, so we can ignore that one. So it's just 0.3571 times $40. And assuming I put everything in the calculator right, I got 13.604. So this should be approximately $13.604. And if we had $13.604 exactly, or whatever this number would be exactly, we could create a portfolio that would have us borrowing some amount of money, buying some amount of stock. How much stock would we have to buy? We'd have to buy delta 0, which is 150 minus 80, which is 70 over the difference here, which is 40. 70 over 40. So we would have to buy approximately, or exactly 1.75 shares, and we would probably have to borrow some amount of money to do that, because that would cost us $175, and we only have 13.6. So we'd have to borrow the rest of the money to get $175, buy 1.75 shares at $100, and all that money that we borrowed, we'd have to pay interest on it at the end of the period. But no matter what happened, we would make $40, or the value of our portfolio would be $40 if the price went up, and would be worth nothing if the price went down. And on average, we will make the risk-free rate of return, because we're not taking risk. Right, so any questions about this example? I think this is a pretty good example that really illustrates everything that could happen. So even though the actual stock had a 50% chance, so would you buy this option? That's the question. Yeah, remember this. We're doing math here, but there's probably a way to view this stuff as not math. I mean, you could think of like, I guess the risk-free rate maybe doesn't have a good analogy, but you could assume the risk-free rate is 0, and you could do all this math the same way, and it could be about something other than money. It could just be like two possible events, and you could have this multiplicative type structure. So I'm sure there's other stuff besides money that you could model this way. Any questions though? So it seems like a good deal to buy this stock though, right? Because it's got a pretty good chance of going up 50%, and if it goes down, it's only going down 20%, right? Not everything is money. Yeah. Also got 13.605. Nice, good. So it was good to get some confirmation. Right, maybe I should just, yeah, this is just 1.75 too, by the way. Okay, anybody need me to repeat any of that? Don is on. Okay, yeah. Yeah, we'll go over in a second. Wait, is that all I had to say? I think I had another page, but it wasn't. Oh yeah, I just started going into the multi-period, but I can wait till Friday to do that. That's not, yeah. Probably not worth starting. Everything is math, yeah. That is one way of looking at it, yeah. Everything is math. But yeah, I mean, I always think of this type of math as possibly being good for, you know, evaluating some sort of quantity of risk in something. It doesn't need to be money, but it could be like you're risking an amount of energy, or you're risking an amount of food, or an amount of manpower, or something like that, where there's some sort of you know, uncertain outcome, and you want to know how much of your, you know, how much of what you own, or how much of your quantity of whatever you have available you want to put into that system and risk it, you know, possibly changing value, right? Yeah, so 13.605 is the price of the option, and it's also the price of the replicating, or sorry, it's the amount of money we would start out with in the replicating portfolio, which then we would borrow money, buy 1.75 shares of stock. And then because of the way all of these numbers are computed, no matter what happens to the stock, we always end up with $40 at the end, or we end up with 0, depending on what happens. And we expect to make the risk-free rate on average, which is 1 plus R. So yeah, the value of the option will be 13.604 or 605, whatever the rounding is. Because it's the value of the starting value of a replicating portfolio that you would need to hedge the option based on, you know, the two things that can happen. Okay, so if there's no more questions, I'll call it here, and I'll put the video on YouTube like usual, and we'll probably just send it over to Don now. So yeah, unless someone stops me. Let's say hi to Don Factorial. Raid them. All right. All right, thanks for coming. We'll do some exercises tomorrow in this stuff, and yeah. Replicating portfolio. Yeah, I'll go more into that when we get into the multi period model. But essentially, it's like we would take this amount of money, and we're gonna take, like I was saying, you either borrow money or your whatever your remaining cash is, but you need to buy this amount of stock, and then you can replicate the outcomes of the option in the value of the portfolio. All right, let's send it over. Yeah, but I'll go into all of this more, so don't worry about that.